So, hello and welcome everyone to Jfokus Brown Bag. We have been doing this for the entire spring now. And today we will talk a little bit about microservices and serverless microservices and orchestration versus choreography. That was a hard English word. And to that, I would like to welcome Mete Atamel from Google. I'm sorry for the pronunciation. Please introduce yourself and do the presentation.
Great. Thanks very much for the intro. I think you did pretty well. It's Mete Atamel, so I think it was pretty close. Much better than what I get in some other places. But before I forget, let me share my screen, because sometimes I tend to do presentations without sharing my screen. So let's do that. And you should see my presentation. If not, please let me know. So hello, everyone. Well, first of all, thanks for having me, and thanks for being here at your lunch hour listening to speak. My name is Mete Atamel. I am a developer advocate at Google. I'm based in London, and today I want to talk to you about this choreography versus orchestration when it comes to not just serverless microservices, but in microservices in general. So the way this presentation will go is that first I want to explain to you what I mean by choreography, what I mean by orchestration, and what are the pros and cons of each approach. Then I want to look at the landscape in this area. So what are the tools that exist in choreography? What are the tools that exist in orchestration? In not just so much detail, just to give you some ideas on some of the services that exist in different cloud providers and some open source projects and things like that. Then I want to zoom into orchestration, because I feel like choreography or also event-driven systems, they're pretty well known and people generally understand them pretty well because they've been around for a long time. But I want to get into orchestration and talk about Google Cloud's orchestrator workflows. And my point of doing that is just to show you what you can expect from an orchestrator tool. So it's kind of like almost like a sample service that you can expect, and what kind of things it can do when you want to orchestrate services instead of choreography. And finally, in the last part of the talk, I want to talk about this little application that me and one of my coworkers, Guillaume Laforge, we wrote initially for a customer to showcase Google Cloud serverless technologies. It was initially written in an event-driven way because that's what we knew. But then when Google Cloud Workflows came along, this was the beginning of this year, we said to ourselves, okay, let's take this app and try to orchestrate it and see if it's better or worse. And it turned out to be really good, actually. We learned quite a few things along the way, and we also were able to compare and contrast the old app and the new app. So I want to finish my talk with that. And I think that's kind of, for me, it's the most useful part of the talk, because it's like a real, not big app, but it's a smallish app where we transformed it and the things that we learned along the way. And then hopefully towards the end, we'll have some Q&A. So if you have any questions, please take a note and I'll answer them at the end of the presentation. All right, and also the presentation is already on Speaker Deck. So if you want to get it, it's there. And the app that I'm going to show is already on GitHub open source. And I'm going to share the link of that as well. So you will have everything at the end of this presentation. All right, so what do we mean by choreography versus orchestration? So let's look at this question through a simple use case. Let's imagine that you are building an e-commerce application, a website, and you have this e-commerce transaction. And of course, I'm simplifying it here. So if someone is actually doing e-commerce, you know that this is a very simplified version of it. But when you look at an e-commerce transaction, it basically involves a certain steps, right? First, you receive a request, then you want to make sure the user can actually pay it. So you authorize the credit card. Then you prepare and get the items together and ship it. And finally, you notify the user that the items are shipped. And then you charge the credit card usually afterwards. So that's usually the flow, simplified flow in an e-commerce transaction. Now, if you need to implement this, what can you do? How can you implement this kind of flow? Well, one way of doing this in the old days is to create a single monolithic application and put all these services together, and you receive the request from this app, you do all the work from this app, and then you finish everything, and then you let the user know that everything is done. Now, of course, I'm sure you all listened all these talks around monoliths and why they are bad and why we should break them down into small microservices. So I won't get into that, but I'm guessing at this point, you're not thinking about putting everything together. So you're probably thinking in terms of microservices, and each microservice is doing something focused, something, a little part of the whole transaction. So on Google Cloud, if you're on Google Cloud, you might be doing it in this way. You might have an App Engine front end, because App Engine is great for web kind of applications that receives a request. Then it passes that request to a Cloud Run, which is a container as a service platform of Google Cloud. So maybe it's a container running some kind of code that authorizing and charging the credit card. Then maybe you pass it to a function to do the shipping, preparing and shipping the items kind of work. And finally, maybe you call a notifier, which is another Cloud Run container that notifies the user, maybe using SendGrid or external service, something like that. Now, in this model, this is basically each service is calling the next service in the chain. So it's like services calling each other directly. And this is one way of doing this. I'm not saying it's the best way, but it's basically the easiest way you can think of initially, where you have small microservices, they're just calling each other directly. Now, when we look at what are the pros and cons of this approach, first of all, this is better than a single monolith. So you have small services that you can deploy independently and you can kind of reason independently. So that's better than having everything in a single place. And it's easy to implement. Basically, each service simply just calls the next service in the chain. So it's easy to reason about. But at the same time, there's a lot of cons right from the beginning. First of all, there's too much coupling. So each service has to know the next service in the chain. So you're already having that kind of leak into your architecture. Each service can be a single point of failure, because let's say some service in the middle fails, then the whole transaction fails unless you do something special. Each service needs to have its own error logic, read-write logic, timeout logic. So you have to kind of implement that somehow in each service, or maybe have something external like Istio to do that, but you have to think about that. And for me, the biggest problem is that who ensures that the whole transaction is successful, right? So if something goes wrong somewhere, who read-write things and who makes sure that the actual, it's a transaction, right? It's, even though it's 4 different services, in the end, it's a transaction that you want to complete fully or not complete at all. So who makes sure that that happens? Right now, nobody really. Now, you can take this and you can try to solve some of these problems. So one way of doing this is you can try to convert this into an event-driven kind of architecture, also known as choreography. And in this architecture, instead of each service calling each other, you can have services emitting messages and consuming messages. So in this model, there is a message broker in the background. So depending on where you run, you're going to have different kind of message brokers like Google Cloud PubSub, Kafka, or others. But basically, the idea is that the request the request comes into front end. Then front end it just emits a message saying that, okay, I received this order, and then the next service in the chain, the payment processor, will receive that message because it's expecting this order request messages. It will act on it, and then it will emit its payment process kind of message. So as you can see in this model, things are more loosely coupled. These services, even though they're called in this order, they don't really know about each other, and they don't really care about each other. All they care about is, these are the messages that I care about, and these are the messages that I'm emitting, right? Now, this is all great for my simple use case, but in an e-commerce application, you usually have things much more complex. For example, in this case, you probably want to receive the order, check your inventory first, then depending on whether you have the inventory or not, do a stock, like determine if there's stock or not. If there's no stock, if there's no stock, you probably want to call a supplier API, a third-party API, and order it for the user. If there is stock, then you want to prepare a message. So you can see there's a flow chart. There's an order of things that needs to happen, and it's not a simple straight line. It's more like a flow chart with branches and things where you do different things depending on the conditions, and you are calling internal services, you're calling external services. So imagine doing this in an event-driven way. you can do it, but I'm pretty sure it will get quite complicated quite fast, right? So the pros and cons of choreography is that services are loosely coupled, which is great. Services can be changed and scaled independently. You don't have a single point of failure per se, because if some service in the middle, they kind of fail, the rest of the services, they can still receive and act on messages and they can emit messages. Now, I'm not saying that the whole transaction is like the whole transaction will be successful. It won't be if a service is failing, but at least the rest of the services will continue to work. So maybe you will have partial success rather than the whole chain kind of failing. And in general, when you have eventing, when you have events, they're really useful as an extension mechanism, right? If you need to extend your system, if you want to add a new service, or if you want to take an existing service and plug it into another kind of workflow, then events really help for that, because in eventing, all you need to do is, how do you make the connection from your message broker to the service? So make the connection, and there's usually different ways of specifying that with topics, queues, or triggers, or whatever you want to call it. But making the connection is usually quite easy thing to do on the fly. Now, in terms of disadvantages, with event-driven systems, you have all these events flying around, and when things go wrong, like, it will be difficult to monitor. You won't be able to see it right away that this service failed. You will see that some message is not processed, but you will have to usually get into the logs and figure out like where something failed, and it won't be as obvious as like this chain failing. So even though things are more flexible, it will be difficult to monitor. The errors and retries and timeouts, they're still a problem. And this business flow, right? For example, this flow chart that I show you, it's a business flow. It's very clear what should happen here. Now, when you convert this to event-driven systems, the business flow, it's not going to be as obvious anymore. It will be almost like a side effect of your event-driven architecture, right? And that can be problematic, because if you want to introduce someone to your team, there's not a single place you can go and show them, okay, this is the business logic that we have. So you have to rely on some kind of documentation or things like that, but the system doesn't tell you what the flow is supposed to be. And the biggest problem that we had from before is still a problem. So who ensures that the whole transaction is successful? You still need to think about that. Now, in orchestration, so you can, again, take these disadvantages of choreography and try to fix them. And you can try to use orchestration. And the idea in orchestration is that you still have your services running independently. You still have your services not calling each other like choreography. But instead of relying on messages, you rely on an external service, an external orchestrator, to do the right thing, to call the services in the order that they're supposed to be called. So in this model, you probably still need a front end. So you have your app engine running in the front end. When it receives an order, instead of calling the next service or instead of sending a message, it will kick off an orchestration that you defined. And this orchestration will be part of an orchestrator. So there's an external service that will run this, and this orchestrator is defined already. So in that definition, it will know to call these services in the order that you defined, and it will make sure that they happen in this order, and if there's any inputs, those inputs are provided. If there's any outputs, those outputs are taken and then sent to the next one in the chain. Now, in this orchestration model, the pros is that, first of all, since you have this orchestrator capturing everything, the business flow can actually be captured centrally. And this is very useful, because now finally you have a place where you can actually point to the business logic and how things are supposed to work. And then since that's captured centrally, you can source control that. And that's also very useful, because once you source control, you can have versions, and every time you need to update, you can update the version, and you can go to the previous version, so on and so forth. So all the things that comes with source control, all the benefits, now you have it for your business logic, which is very useful. Each step in orchestration can be monitored by the orchestrator, and we'll see that actually when I show the example. So you can see each step, and you can see when something fails, where it fails. So it's not like event-driven systems where things just fail and you have to figure it out. You can see it exactly where it failed. If you want to apply error policies, retry policies, timeout policies, this can be done centrally, meaning in the orchestrator, you can define how you want things to be, retried and how much to wait, things like that. And this can be very useful. And in orchestrators, you can rely on just simple HTTP calls, because with event-driven systems, you have events, you have different types of events, you have event parsing. So there's a lot of complexity that comes with eventing. But with orchestrators, you can simply deploy regular services that understand HTTP, and orchestrator can use that HTTP to call your services. So arguably, it can be simpler than eventing because you're just using plain REST. And the good news is that your services are still independent. They can be deployed independently, they can run independently, but they're kind of captured together into this orchestration. So it's almost like you're kind of putting them together without creating the monolith anymore. It's just an orchestration that you can define and you can change as you go along. But the deployment and the independence of the services, it's still maintained. Now, of course, nothing is perfect. So with orchestration, now you have this orchestrator service. It's a new service that you need to worry about and maintain. And you need to think about that. Orchestrator arguably can be a single point of failure. So because if orchestrator service is not working, then your whole chain doesn't work. So you need to make sure that you're using an orchestrator that's reliable and resilient and redundant and all that kind of stuff. And you are losing the eventing flexibility, right? Because in eventing, as I mentioned, you can plug things in. You can plug in services as you need them. But with orchestrator, you need to create an orchestration. You need to define the orchestration. And if you need to include a service, it's not just including the service. You need to also change the orchestration definition, and you need to deploy that. So there's a little bit of flexibility that's being lost there. But that's the price that you pay for having the structure that comes with orchestration. All right, so at this point, you might be wondering, okay, choreography, orchestration, which one is better? Or is orchestration always better? So on and so forth. And I think that the answer really depends on what you're trying to achieve. Usually what I see is that if you have services that are not really close to related to each other, then it's better to put them in event-driven kind of architecture, because the services, they don't need to talk to each other, they don't need to call each other in a certain way. They just need to do their work and let others know that I finished this work, and then let others do their part if they care to do it. So if services are not closely related, and if services, they can exist in different contexts. For example, if you have a notification service, it can be part of an e-commerce transaction, but it can also be part of some kind of service failure kind of notification, right? So it can live in different contexts. And for those kind of services, if you design it in an event-driven way, you can probably have an easier time moving it around to different places, right? But on the other hand, if you have a business logic where you can clearly define it in a flow chart, where just like I showed you before, where certain things happen in a certain way with certain conditions and so on and so forth, then at that point, maybe you want to think about orchestration, because you probably have services that are related to each other, that always go together, that always call each other in a certain way, depending on certain conditions. So there's all this kind of need for things to go together, right? So if you feel that need, then maybe it's a good time to start thinking about orchestration. And also, orchestration usually works with REST. So if you want to avoid the complexity of eventing in general, maybe even though services might not be related, but you just want to stay in REST, maybe orchestration can be a good option as well. So it really depends on what you are trying to achieve with your systems. And of course, you don't have to choose one or the other. You can also have a hybrid kind of approach where, maybe things that go together, you put them in an orchestration, like an e-commerce transaction. And then when that e-commerce transaction is done, maybe you want to notify other orchestrations that, this is done, and then other things might happen after that, right? So in that model, you have an orchestration in a bounded context, but then these orchestrations, they communicate via messages. That can be an option as well. So you basically can pick and choose the kind of structure you need for orchestration. and also the kind of flexibility that you need with your event-driven systems. All right, so that was a really quick overview of choreography, orchestration, which one is better, which one is not, and pros and cons. So hopefully now you have an idea on what I mean by choreography and orchestration. Now, when we look at this landscape on what kind of services and tools exist in this space, when we look at event-driven systems, this is not a full list, but just a quick overview in this space is that, no matter where you run, in which cloud, AWS, Azure, Google Cloud, there's a number of eventing kind of systems, like EventBridge on AWS. On Azure, I mostly hear EventGrid. On Google Cloud, there's PubSub and EventArc, and there's open source tools like Kafka and others. So there's a lot of option here. In orchestration, since it's relatively new, there's less options. On AWS, I think step functions in general, they're more like orchestration, even though it's not a fully fledged orchestration like workflows. It's still, I think, it can be considered an orchestration kind of tool. On Azure, there's logic apps, which is, again, kind of like step functions, but it has more, you can also write more logic on top. And on Google Cloud, there's workflows, which is, again, an orchestration tool that also has some kind of logic built into it that you can do within the orchestration. There's also Apache Airflow for data orchestration, and the managed version of that called Cloud Composer on Google Cloud, which is managed Apache Airflow on Google Cloud. But this is more for data orchestration rather than service orchestration. So for service orchestration, I would suggest workflows on Google Cloud. And there's also a serverless workflow specification that's coming up. This is an open source specification from CNCF that's being worked on. And it tries to be this basically open source definition language for workflows. Right now, I don't think any of the cloud providers are implementing it in any way, but it's something that I'm watching, and I'm interested in what comes out of it. So ideally, at some point, there will be a common language where you define your workflows, and then you can deploy it into multiple places. Maybe it will happen, maybe not, but it's something to watch out for as well. All right, now I want to talk about the orchestration in more detail. So I'm going to talk about Google Cloud Workflows, what kind of things it provides. And then finally, we'll look at the demo application and get into details of how we took it and how we orchestrated it and what we learned along the way. All right, so what is Google Cloud Workflows? Google Cloud Workflows, it's a service, it's a cloud service that lets you orchestrate and integrate a bunch of different things. First of all, it lets you orchestrate serverless compute. So these are places where you can run code on Google Cloud in a serverless way, such as App Engine for web applications, Cloud Run for serverless containers, Cloud Functions for serverless functions. So all of these can be orchestrated using workflows. You can also orchestrate any Google APIs. So any Google Cloud APIs like Vision API, any kind of HTTP API like Gmail and things like that, you can put into your orchestration. And also you can orchestrate external APIs. So if you have to call an external service, like a third-party API, as long as it understands HTTP or HTTPS, you can include them in your orchestration. And I like this because most of the time when you are trying to do something, it doesn't just involve the things that you run in your cluster or in your service. It usually involves a bunch of different things from different providers. So workflows allows you to bring those into a single orchestration, if you wish. Now, in terms of how you define your workflow, there's a workflow definition language. It is in YAML or JSON syntax. Here, I'm showing the YAML syntax. So if we go back to our previous example, let's say you have this payment processor, shipper, and notifier running on Cloud Run, Cloud Functions, and Cloud Run, and you want to orchestrate this in this order, what you could do is you can basically define what's called steps in workflows. You can give your steps a name. You can specify how the step is being called with HTTP post or HTTP get, where the step URL is, and then what you pass into the step. So in this case, we are passing payment details to our payment processor that we will receive from previous step. Then once that's called, so this call is being made by workflows, then workflow will receive the result and we can save that result into a variable, in this case, process result. Then in the next step, we can make a call with the body from that result. So you can see that we can get the result and we can parse parts of the result and we can pass it to the next step and so on and so forth. So that's how you define your workflow. And this can be done in JSON as well. In steps, and this is like a regular steps. So one service calling another service. There's serverless pause, where a step can be called with some delay that you define, and then you can also pass variables between steps, and you can parse them as well. There's a simple JSON parsing logic within workflows where you can define it in YAML and say, okay, I want to parse this part of the result and pass it to the next step. It's not perfect, so you can't do everything with this JSON parsing. So it's not like a fully fledged JSON library yet, but it does the basics that you might need. And on top of that, you have this, I mentioned this, like errors and retries. You usually want to apply these in a global way, and workflows allows you that. So in workflows, for example, you can say, in each step, I want to call my service. And if it fails, I want to try 5 times before I fail. And I want to do this 5 times in an exponentially backoff kind of way, right? So you can specify this number of times, timeouts, the policy, the exponential backoff, and other things. So you can define these in each step, or you can also define them globally as well, so that you can let workflow do them in a global way. And also, depending on what happens in a step, you can take different routes. So if the step returns some HTTP success code, you can call another service. Or if the HTTP call failed with some kind of error code, then you can call another service. So doing this kind of branching is quite easy in workflows. On top of that, you have conditionals. So for example, in this case, let's say you make a call to a database, you get a value on some inventory number. You can check that number within your workflow. And then if the number is more than 0, that means you're not out of stock. Then you branch it to one part of the orchestration. But if it is out of stock, then you can branch it to another one. So this check that you do out of stock, that can be done in the orchestration rather than deploying code to do this. And then I mentioned this already, but you can call any kind of third-party APIs that's possible, which is really useful. And the last couple of things I want to mention is that you can externalize your workflows into sub-workflows. This is kind of like defining a method call, right? Defining a method, and then you can call it from multiple places. Just like that, you can do a sub-workflow, and then you call it from multiple workflows. And then we also introduce connectors, which is an easy way to call Google Cloud Services. And connectors, they also have intelligence built into them, so that you can, for example, if let's say you want to create a new virtual machine in a workflow, the virtual machine creation takes some time. Normally, the way you should do this is that you need to kick off the call to create the virtual machine, and then you need to keep polling and make sure that the virtual machine started before you say, okay, workflow succeeded. Now you can do this yourself with HTTP calls and with polling and all that, but it becomes quite complicated quite easily. Whereas workflows has a connector, computer engine connector, that will basically say create a VM and start it. So the connector will do that for you, and it will wait and it will retry until it's up and running. And this really simplifies your workflow. And you don't have to do that retry logic and polling yourself. And to deploy a workflow, you can do it from command line. So define your YAML and just deploy. This deploys a workflow, but it doesn't run it. Then you can execute the workflow with the execute command. And then once it's running, you can see how your workflow is running, or the result of it if it's finished using this command. Of course, everything is also UI based. So you can go to Google Cloud Console, and you can look at the source of your workflow. You can get like visual representation of your workflow. So you get so this is kind of like the flow chart of your business logic basically, and see what happens. And you can execute things, and you can see the logs and all that. And I'm going to show you this shortly in our demo application. All right, so that's Google Cloud Workflows. And Now I want to talk about this application that I mentioned at the beginning of my talk. So this application called Piccadilly, it's a services-based picture sharing application that me and one of my coworkers built for a customer in London. So that's why we call it Piccadilly, because London has a Piccadilly Circus, and then it's a picture sharing app. So we combine the names to call it Piccadilly. But in this app, what we do is that it's a simple app where users upload images, and then once the images are uploaded, we use machine learning to analyze the image. So a couple of things that we do is that first we extract the image labels. So here, for example, we extracted these labels from this image, and these are the labels for this image. And we also extract the dominant color of the image and put that as a border around the image, right? So the users upload the image, we analyze it, pick the labels, pick the dominant color, and we display them. So that's number one. And the second part is that there's a collage part of the application where it displays the 4 most recent pictures in a collage. So it puts them together in a collage, and I will show you this in the application. But basically, it's a very simple picture sharing application that has a little bit of intelligence built into it. And there's actually a code lab where you can build this application yourself. And this is the link, and I'm going to share the link at the end of the presentation. And initially, we built this application using event-driven architecture. And this is what the event-driven architecture looked like. And just to give you a quick overview of how this worked, we have users uploading pictures through an App Engine front end. And when this picture goes to a Google Cloud Storage bucket, that triggers a number of messages. Now, first message went to this cloud function called image analysis. And this image analysis function will use Vision API to analyze the picture and save the metadata of the picture, like the labels and the dominant colors, into Firestore, which is a NoSQL database. Now, the second event went to another service called Cloud Run Thumbnail service. This is a Cloud Run service, so it's a container that's running. And you'll realize that it's going through PubSub because Cloud Storage and Cloud Run, they don't have native integration yet. So you have to go through PubSub to get the events. And then this service will resize the image into a smaller version and save it to another bucket. Then we have another service called Collage Service that runs on a schedule. And it will go and look at these thumbnails, and it will figure out the 4 most recent pictures from Firestore database, and it will create a collage out of these pictures. And then the last service, it's another Cloud Run service called Image Garbage Collector service. And what this does is that when an image is deleted, it will trigger an event, and this service will delete the thumbnail of the picture, and it will delete the metadata of the picture. So it will do a little bit of cleanup of the image. And this goes through yet another event system called Event Arc, which is the new eventing system of Google Cloud. So as you can see in this simple application, we have 3 or 4 services. They're receiving different events, but it's already 3 different types of events. One Cloud Function event. The second one is Cloud Run event through PubSub. And the third event is Cloud event through Event Arc, right? So we are dealing with 3 different types of events already. And we were already running into problems though, like, sometimes we would upload a picture and it wouldn't, like, we just don't see the picture being processed, and we didn't know why. So we would have to look at all these services, look at the logs, see which one didn't fire, things like that. So all the problems that I talked about with choreography, we started having them even in this simple kind of application. So that's when we started looking into workflows and see how we can create a workflow out of this architecture. And this is what we came up with. And by the way, these 3 different event types I mentioned to you, you can see in the code as well. This is not JS code. You can see that the event processing was also different for each service. In Cloud Function, it was just pure events that we get from Cloud Functions. In Cloud Run thumbnail service, we were getting PubSub message, and the data of that service, or the PubSub message, was the actual event with the Cloud Storage event, and it was base 64 encoded. And then the event for image garbage collector was a cloud event. So we had to parse the cloud event using cloud event SDK and get the audio log, and from there get the actual event. So you can see the complexity that was already arising with event parsing. So now we converted this into orchestration. And even though this picture looks more complicated, actually it's not, because this flowchart, this whole flowchart, it's just a single service, workflow service does all this work. And the way this works is that we have the user uploading an image to an App Engine frontend. Then this picture goes to a bucket, just like before, that triggers an event to a cloud function. So that's still similar to before. But then from then on, so by the way, this trigger can be for file creation and also for file deletion as well. And then from then on, it's just a workflow that gets triggered. So this cloud function will kickstart the workflow. Then workflow will start and it will do the check. Which event type is this? Is this a creation event or is this an object deletion event? If it's creation event, it will make a call to Vision API. So the workflow does that Vision API call. Then it will transform the data that it receives using a cloud function. Then it will determine if the image is safe within the workflow. Then it will store the metadata to Cloud Firestore, again within the workflow. And then it will call the thumbnail service and the collage service by making a call to Cloud Run Services. And then if the object is deleted, it will do the garbage collection again from the workflow. Now, in this model, you can see that, first of all, it's kind of very clear what's happening. You can see this in the workflow definition. And also, you can also see that the workflow, some of the work is being done within the workflow by itself. Like, for example, image analysis is not a function anymore. It's just done within workflow. Or garbage collection, it's not a service anymore. It's done within the workflow. But for some things, you can delegate. And that's what we did with thumbnail and collage. We just delegated to the service. So you can kind of pick and choose where you do the work. And let me show you this app. So this is my app. You can see I have some pictures here. And I'm in Google Cloud Console. And if I go to workflows, you can see I have this Piccadilly workflows. And if you look at the executions, you can see when I run this, you can look at the logs, details, and if you look at the source, this is actually the definition of the workflow. So you can see the YAML. I won't go through it here because we're running out of time, but it's out on GitHub. You can take a look in detail, but you can see that some of the logic is here and some of the logic is being done by calling the actual services like the picture garbage collector or the calls to Cloud Run Services. It's somewhere here. It's being done in an external service. And then you can see the visualization here. So the business logic can be visualized here. And if I actually come here and upload a picture, so let me just upload a picture. And let me choose a picture of just myself and see how that's going to be analyzed. So we are now, I'm submitting. So if everything working, then now the workflow should be executing. And if I look at executions, let's see. I need to come back. Today is, oh yeah, you can see it was quick. So it ran just now. And if I click on the execution ID, you can see
Oh, we just completely lost your sound. At least I did.
okay.
Perfect.
Can you hear me now?
Yes.
Okay, sorry about that. Yeah, I got like, it says your internet connection is unstable, so maybe it's because of that. But hopefully it will be okay. And then in the output, you can see that these are the outputs from my services, and I am just outputting my HTTP codes that I receive from the services. So this gives you an idea of inputs and outputs. And then if we go back to our app, and if I do a refresh, yeah, I see my picture. It's already been analyzed with things. So, and then if you look at the logs as well, we can see the logs of workflows. So this gives you an idea on how workflows works and how we transform our application. Now, in terms of what we learned doing this transformation is that, first of all, converting our application from event-driven to simple REST calls, because orchestration was really refreshing, because we could get rid of these 3 different eventing formats and all this eventing complexity, basically, and just rely on simple REST. So that was really useful. We got rid of a bunch of code, so we don't have to parse events. We don't have to do image analysis cloud function. We don't have to write a function for garbage collection. Instead, we can do those from workflows. We don't have to do much setup, because we don't have to set up PubSub, no scheduler, no event arc, so no event-driven things and no scheduling things, because workflow captures all of that. So instead of 3 services, we can rely on 1 service. And the error and retry handling was simplified as well, because we can, again, do everything within the workflow without having to write code in our services. Now, in terms of disadvantages, now workflows is a new service with its own syntax and YAML and its quirks and limitations. So it's something that you need to learn and get used to. Then you need to convert a lot of things. Like we got rid of lots of services, meaning we got rid of code, but you need to convert that code into YAML or JSON in workflows, right? So it's questionable, actually, which one is better. Like, I mean, is it better to do things in code, or is it better in YAML? If for simple things, it's probably better to do it in YAML, because it's just a couple of lines of YAML. But if things get complicated, then I argue that code is probably better, because you can test it better instead of relying it in the YAML. And also, right now in workflows, everything has to be in a single YAML file. So that YAML file can get quite big, although you can use Terraform to kind of combine multiple YAMLs together if you like. But in the simple case, a single YAML file might be too much. Debugging, testing, logging, it works in workflows, but it's not like you can't have a unit test, for example, for your workflow, right? It's not there yet. So it's hard to test your code per se, because you don't have the capability for unit testing. So most of the time, for me to test things, I have to deploy and see that it works, which is not great. And there's not much IDE support either yet. Again, if you write your orchestration, the only way to know if it's correct is to deploy it, and then at that point you get an error. But this is going to be improved going forward. And then in workflows, the way we wrote is that everything is sequential, but we lost a little bit of parallelism of eventing and the flexibility of eventing as well. But that's kind of what we wanted in a way. We wanted things to be less flexible so that we can kind of track them a little bit better. Okay, I went a little bit too much. I was hoping to finish this in 40 minutes, but it's a little bit more. So I will stop here. But if you want the links, so this is the Cloud Workflows link, and then the serverless workshop. So if you want to build this app, both the event-driven way or the orchestrated way, this is the link, and we have 6 labs to do it. So feel free to check it out. And if you have any feedback, let me know. And the code itself, all of the code is on GitHub, and this is the link as well. Thanks very much for listening. So I'll just pause now and see if anyone have any questions or comments. Thanks very much.
Thank you very much. So I wonder, could you quickly just copy those links and then maybe put them in the chat so that easily for people that are joining the call to get that quickly?
Yeah, sure. Let's do that now.
And with that said, I would also stop the recording.